Hello everyone. This is going to be the first video of a new series that I'm going to create. It's a series for physics, more specifically for my physics competition, because to be honest, I create these videos for my own revision, but I thought it would be pretty fun if I just post them on YouTube. So yeah, basically my plan for this physics series is as follows. The content that I'm gonna cover is much more advanced than most of high school curriculum physics. For example, the IB physics. In this series of videos, I'm gonna cover calculus-based physics, which is not covered in high school curriculum IB physics. I would say it's more close to AP Physics C in the US. So yeah. I'm gonna briefly introduce what I'm gonna cover for this series. This will probably take around 1 to 2 weeks because I'm just gonna cover those really quickly. So first of all, I'm going to cover the fundamentals of physics, which is basically about units, physical quantities, standard units, and most importantly, vectors. Vectors is basically a quantity that is so important in physics that every single topic uses vectors. So it's very important to introduce this kind of concept first. And even in IB math, we only cover vectors until later units, probably even after calculus. So it's very important to cover it in the first chapter of the physics series. The second topic I'm going to cover is basically classical mechanics. And in classical mechanics, we're going to cover kinematics, which is basically the motion of, um, of an object. And in kinematics, we're probably going to cover 1D kinematics and 2D and 3D kinematics. But mostly we will focus on 2D kinematics. Another topic that we're going to cover is motion of force in Newton's laws. This one is not going to be really difficult because we're just basically going to cover the three laws of Newton's three laws in depth, and we're probably going to do some, somewhat difficult calculus-based questions, mechanics questions, and including momentum and stuff. C is energy, and energy there's not really much to say because conservation of energy is pretty important in mechanics. And D, rotational mechanics, is going to be a really big topic because there's essentially two kinds of motion in classical mechanics. One is translation, which is kinematics basically. The other one is just rotations. And rotational mechanics is going to be quite different, I would say. And at the end, we will combine both this motion of translation and rotation together so that we can do some problems about that. Topic 3 is also quite important, and it's waves. Basically, in waves, what we're going to cover is simple harmonic motion. And the reason I didn't group simple harmonic motion is because I thought its motion is more of like a periodic wave. So it would be better if I group in the waves. And we're also probably going to talk about sound and stuff. And perhaps, if possible, we will even talk about more advanced stuff about wave equations and stuff. But even for me, I'm not really familiar with this concept, so we will see. The fourth topic is thermodynamics. Thermodynamics is again a very important topic. In thermodynamics, we're definitely going to cover temperature and heat, the thermal properties, and the two laws of thermodynamics. In thermodynamics, we're going to cover heat and temperature, thermal properties, as I said, and also the two laws of thermodynamics. We're not going to cover the third law because it's not important for the moment. After thermodynamics, there's going to be a really, really big topic, the electromagnetism, and I numbered it incorrectly. It's number 5. So basically in electromagnetism, there's so much topics. We're going to first cover electrostatics, which is, we're going to talk about electric charge, electric field, Gauss' law, which is definitely not covered in IB physics. We're going to talk about electric potential and stuff. And after that, we're going to talk about capacitance and dielectrics, which are essentially also kind of electrostatics. After this, we're going to move on to some simpler topic, which is direct current circuits. We're going to talk about current, resistance, and EMF. And in this topic, we're not going to encounter a lot of math, and it's not going to be really difficult. However, after that, which is magnetostatics is going to be, there's so much math. Basically, it's a topic about magnetic fields and magnetic forces. This topic is quite interesting because in IB physics, we actually never talk about how to calculate the magnitude of, a magnetic field using the current only, or even a singular charge. So a lot of calculus is involved. And after magnetostatics, we've already covered electricity and magnetism. So definitely we're going to cover electromagnetism, and electromagnetic induction is one of the bigger topics in electromagnetism, and it's really math based, and I personally think it's the most difficult topic out of all the physics topics. After that, we're going to have inductance, alternating currents, and finally, I would say electromagnetic waves is probably the hardest. The reason I didn't group electromagnetic waves into the topic waves, because it's more, you have to have a good foundation of electromagnetism in order to understand electromagnetic waves. So yeah. And that's not it. We're still going to have optics and modern physics. For optics, we're going to cover light, the basic nature and propagation of light. And optics is a much light-hearted and not as mathematical as electromagnetism topic. So it's probably going to be, somewhat of a relief. And it's pretty fun as well. It does more, for example, for geometric optics, we're gonna do a lot of geometry stuff. So it's more math-like instead of physics-like. But again, when I said math-like, I don't mean calculus stuff. It's just geometry. So yeah. And after geometric optics, we're gonna study interference, which is another very interesting topic. The last unit of the series is going to be modern physics, which I think I myself is the most unfamiliar with, but I think it's the most interesting part. Basically, we're going to cover the postulates of Einstein's postulates. We're going to cover his special relativity, and probably even general relativity. And then we're going to cover some modern physics stuff like photons, light waves, and particles as behaving like waves and stuff. And it's for myself, I don't really have a great confidence in doing these stuff. So I'm probably not gonna. This is probably the unit where I explain the least well in. So yeah. However, I think it's the most fun unit, especially for the last unit, which is quantum physics, and it's just fascinating. So I hope you guys enjoy this series, and I'll see you soon in the next few videos on classical mechanics. So see you.